ultimate route to JEE success with JEE Test Prep app by Extramarks, adaptive testing platform, India's top faculty, micro-scheduling, live and recorded sessions, doubt-solving sessions, national level weekly tests, analytics and reports. Download the app now.
Hello students, today we are going to discuss about simple harmonic motion continuing the chapter oscillations. This topic is very important for all competitive level of exams so that you can prepare this chapter very well thoroughly and practice number of questions. Physics is the subject, by reading it won't come, by solving number of questions only it will come. So try to practice. Okay, now let us start the session. We are talking about simple harmonic motion. And some problems based on the basic equations of simple harmonic motion. You can see here, this is the ball which is oscillating about to and fro motion, like about the mean position. This is called as mean position, or sometimes people may call this as equilibrium position as well. And this is extreme position, and this is also as well as extreme position. Every distance is measured from the mean position. Okay, and now at time t is equal to 0, particle starts its motion from position A. From here it started, from amplitude it started. So as I said, if you go for y is equal to a sin omega t or a cos omega t, a sin omega t or a cos omega t, which are periodic functions, then you will try to get an oscillatory equation that in the next session we will see. But now, if you see this, how the particle is oscillating. Particle starts from here and it came here. So quarter oscillation done, and then again from mean position to the left extreme, one more quarter oscillation done. Then here to here it came back, now one more oscillation done, quarter. Finally here to here it came back, one oscillation. You can see when here to here it came t by 4 time, when here to here it came t by 2 time, when here to here it came then 3t by 4 time, and finally it reaches t time. And you see the arrow mark here, initially starts from rest, and when it is moving like this, as I said, spring force is acting and it will pull. When force is acting in the direction of displacement, force will try to accelerate the body. The speed goes on increasing till here. Now when it comes here, now spring will start compression after this left. So what will happen? Compression makes that there is an opposition by the spring on the block. So speed, length of the arrow, you see, speed goes on decreasing, and finally it will come to rest. When it comes to rest, spring is under more compression. Now spring will push it. So spring force is in the direction of motion of the body. So velocity goes on increasing till here. Then after this situation, spring is under expansion, and hence it will act like this. It will keep on oscillating. Now, if we talk about the spring, now if we talk about a football, if you see, if Ronaldo is hitting this, then it will go to certain distance and it will stop. Why it was stopping? So you have to understand that V at this position is 0. This is the starting point at time t is equal to 0. Then what I mean to say, this was stopping means velocity goes on decreasing because it is under retardation. Now if you see this football, velocity goes on decreasing. Why? That means acceleration is in this direction. You know, when you throw an object, when you throw an object up, velocity goes on decreasing and final velocity becomes zero. Why? Acceleration due to gravity is pulling that down. So this is called as retardation. Generally, students have misconcept that acceleration, if at all it is negative, that is called as retardation. But acceleration is called as retardation even though it is positive. The situation is when the situation is like this. How? When velocity is exactly opposite to acceleration, then only we can call it as retardation. Remember this. When the velocity direction and acceleration direction are in opposite, then that is called as retardation. Minus a signifies that the direction of acceleration. It doesn't mean that it is retardation. Now, so acceleration, velocity both are in opposite direction when he kicked. But here if you go, when the ball is coming down, velocity goes on increasing by acceleration, velocity both are in same direction. When acceleration, velocity both are in same direction, then obviously speed goes on increasing. That is called as accelerated motion. And now you can see here, when the same person, when he kicked the ball this side, here also velocity becomes zero after a long journey. But why? Because acceleration is acting towards him, towards the starting point. That means velocity, acceleration both are in opposite direction. When opposite direction, then we can call it as retardation. Now coming to the point, in the situation 1 or in the situation 2, quite interesting point is acceleration always acting towards the starting point. Then obviously body will retard. The same sense, you can see here, if I take the spring block system, if I take the spring block system and if I extend, or if I pull the block of mass m till here, with the help of hand somebody is pulling, so then till here, then extension is there in the spring. You can see here, when I release this is the starting point, released from rest. When I release this, obviously what will happen? This spring will pull it back. So the spring force is like this, restoring force, and this body will accelerate. Why? Acceleration, velocity is in the same direction. Now till here it was accelerating, so at this point velocity is maximum. Now after this, spring starts compression. So obviously it will retard. Why? Spring force is in this direction, means acceleration is in this direction, velocity is in this direction, both are in opposite direction, so speed goes on decreasing. But still you see acceleration here and here towards, like how the football acceleration is playing, the same sense the block acceleration is also acting. That means in football case, ball won't come back, but in spring block system, ball will come back because of what force? Restoring force. Restoring force. And that force is always acting towards this position. You know, central position is called as mean position. This position is called as extreme position. This is also called as extreme position. So in SHM, it is to be noted that always force acts towards the what force? Restoring force. Always restoring force acts towards the mean position. This is called as mean position. And how much is that? It is the crystal clear. F is that restoring force is spring force in Newton's laws of motion. You had been studied this. That is minus k x power 1. This one decides this one. If x power 1 is there, that only decides by saying that I am in simple harmonic motion. So the body which is in simple harmonic motion can also be called as simple harmonic oscillator. Now, for that, mathematically, because when this block is oscillating, that is in SHM. So, what was the displacement of that block at every instant? It was changing, and every distance measured from mean position. Okay, fine. So, and whenever it is under oscillation, it must be periodic. So, we have to depend on one function, which is the function of time, like y is equal to a sin omega t or cos omega t. So y is a function of time, of course sine function and cos function trigonometric, they are periodic obviously, because if it is oscillatory, damn sure that must be periodic. Other than sine cos, if you take tan or something log, they are not at all periodic, as we discussed in the last session. But right now we are concentrating on periodic functions. So here I took xt, along x-axis block is oscillating, a is cos omega t plus y. What is a? Amplitude. किसका amplitude? Displacement amplitude. Whose amplitude? Displacement. And this is cos function. It doesn't mean sine is not valid. Sine and cos both are periodic. And this is whole is called as phase angle. Phase angle. And this omega angular frequency. And phi is called as phase constant or initial phase. Sometimes we can call it as epoch. Now, this is cos function. So at time t is equal to 0, it starts from here. Now it will vary like this. The equation and the corresponding graph, that represents obviously SHM. SHM that also represented by, as I discussed, also represented by sine wave. Understood, ma'am? Okay. Now coming to the amplitude. Whenever we are talking about periodic motion, whenever we are talking about periodic motion, it is mandatory that amplitude must be constant if it is under oscillatory. So amplitude must be constant. So you see here it is upper half, here it is lower half, and here it is upper half, because once it start from right side, it should come to left side, then it should go to here and it should come to left. Means extreme, if it started, then it should go through mean first, then toward the other extreme, then it should come to mean, then it should come to extreme, then one complete oscillation completed. So one oscillation angular frequency is 2 pi by t. T is the time period of one oscillation. Now, we already studied about the quantity omega t plus phi. Obviously, the equation is known as phase of motion, phase angle. Where it is also known as, the phase angle or phase constant. Phase of vibrating particle at any instant is a physical quantity that completely describes the position and direction of motion. Phase means the situation, where it was standing, in what direction it was moving. So phase angle represents always the position and the direction of motion of the particle at the given instant with respect to mean position. Now, equation of SHM. F, this is directly proportional to minus x power n. So I have to discuss here some important points. So here this is F directly proportional to minus x power n. So I can write it as F is equal to minus kx power n. N value. You should understand this. What about n value here? N value, there is a significance. It's an integer. So then if n is odd and if n is even, so sometimes they will ask you by giving the equations, f is equal to minus 2 x minus 2 whole square, x minus 2 whole cube, like that, by climbing about what type of motion this equation does represent. So by seeing the equation itself, no need to worry, seeing n power value, you can claim whether it is translatory or oscillatory. So that clues I am giving right now, so please concentrate. Odd, even. Odd means 1, 3, 5, 7 and so on, which are not divided by 2. You know that even is nothing but 2, 4, 6 and all. So whenever n is odd number, obviously it must be oscillatory, odd. Then if it is even, it should be translatory. Translatory means there is no to and fro motion, it is moving in only in one direction. Oscillatory means it is moving front back. If suppose you are seeing my head, so that you consider it as me, so that should be left and then right and then left and then right, touching extreme positions on both sides. Then if it comes to its original position, then one oscillation done. Understood? So now this is 1, 3, 5, 7 and this is 2, 4, 6. So if the expression is like this, f is equal to minus 2 x minus 2 whole square. Don't bother about this, you treat this whole as x. Then whole power 2 is there, 2 to even number, so directly you can claim translatory. What do you mean by translatory? Force is acting in only one direction. If it is accelerating, it should accelerate till it reaches the destination. If it is decelerating, it should decelerate till it comes to rest. So if instead of 2, if it is 3, then oscillatory, it is compulsory. How and all? By giving using some problems we will see that. But coming to the point, if x is equal to 1, n is equal to 1, that is the special case where SHM is taking place, then obviously that is x is equal to 1, though that is treated as SHM, because if n is equal to 1, that is odd, that is oscillatory, so it can be SHM. Every oscillatory is not SHM, but every SHM must be oscillatory. One more, every oscillatory motion is periodic, but every periodic is not oscillatory. These are the two statements. Let me write here. Every oscillatory is periodic, vice versa is not true, and every SHM is oscillatory. Now coming to the equation, what we had been studied, that is f is equal to minus kx. F is equal to what? Minus kx. Then what is f? ma. F is equal to ma, which is equal to minus kx. And now what is a? A is equal to, I can claim like this, minus k by m x. Now finally I can write this as a plus k by m into x is equal to 0. Now what is a? A is nothing but d square x by dt square. Don't think that this a is amplitude, this a is acceleration due to the restoring force. Okay, and now this can be written as k by m is nothing but omega square. So instead of saying k by m and all directly, I had been given the expression like this. But remember, where omega square is nothing but k by m. D square x by dt square is nothing but acceleration, you know that. So this is a differential equation of SHM. So for every equation, second order differential equation, because this is d square, for every equation there should be a solution. What was that? You can see if y is equal to a sine omega t. Let us differentiate this. What was this then? D square, first one time differentiation, dy by dt is equal to a sine omega t differentiation, omega comes out, cos omega t, right? Then if you differentiate this once again, of course, first time differentiation velocity, next time differentiation acceleration. You can see this cos theta differentiation minus cos omega t differentiation, omega should come out, already one omega is there, so that will become a omega square cos theta differentiation minus sine theta, that is sine omega t. You can see this a is equal to minus omega square, a sine omega t can be written as y. So this is nothing but this is d square y by dt square. This comes this side plus omega square y is equal to 0. So from the solution we are getting the question. So the solution is satisfying. Hence y is equal to a sin omega t or a cos omega t are periodic functions which represents SHM equation as well. Okay. Now coming to one question, simple question as we discussed. F is equal to minus 2 x minus 2 whole cube. Let me say whole cube. First question they are asking, if suppose they are asking where is the equilibrium position. Equilibrium position, you know, in rotational motion you had been studied that equilibrium means force should be 0. Equilibrium means force should be 0. Force is 0 when it will happen? When x is 2. 2 minus 2 becomes 0. Means that equilibrium position at x is equal to 2. At x is equal to what? 2. So now let me draw one line. This is x is equal to 2. Mean position or equilibrium position. Now let me take this side obviously x greater than 2 and this side obviously x less than 2. Let me take at x is equal to 3. At x is equal to 3. Put 3 minus 2, 1. 1 cube is 1 minus 2. Force is acting negative side. How the force is acting? Minus 2, negative side. Now if you go for x is equal to 1. X is equal to 1. You see 1 minus 2 whole cube, that is minus 1 whole cube, that is minus 1. Minus into minus plus 2. Means force is acting in this direction. So quite interesting, like football, you see, like spring block system. Force is acting always towards mean position. So when the force is reverting its direction as per the displacement, means opposite to the displacement, then that force is called as restoring force. Then here we got it was oscillating, trying to oscillate. Why? This force every time it was trying to restore back, restore front, like that. Hence it is under oscillatory motion. But every oscillatory is not at all SHM. For SHM, condition is mandatory, x power 1 is required. X power 1 is required, but here x power 3 is there. So this is not at all SHM. This is completely odd number. I said if it is odd, oscillatory. Then check if it is one oscillatory as well as SHM. Now let us see a small change in this equation whole square. So where is the equilibrium position? You can say equilibrium position because net force is 0. Where is the equilibrium position? When x is equal to 2, F is equal to 0. So here force. Okay, fine. But when x is equal to greater than 2, what will happen? Less than 2, what will happen? Let us say x is equal to 3. At x is equal to 3, particle is at x is equal to 3. 3 minus 2, 1. 1 square to 1 square. 1 square into minus 2 minus 2. Means force is acting in this direction. Okay, fine. At x is equal to 1. 1 minus 2 minus 1. Minus 1 whole square. 1. 1 into minus 2 minus 2. Means here force is still acting in the same direction. So it was not reverting. So it is to be understand. This will happen once the body is in what type of motion? Translatory motion. When force is not reverting, it is not at all oscillatory. If at all this is not oscillatory, that is not SHM. Now coming to this question. A simple harmonic oscillation is represented by this expression. You can see without going into the solution only we can solve here. Compare y is equal to a sine omega t plus phi naught. So it is very clear. What is in place of a? 0.40. So that is amplitude. What is omega? 440. But they are asking frequency, which is 2 pi f. Then obviously f is 220 by pi. Right? Then what about time period? The time period is, time period is 2 pi by omega. That is pi by omega is 440. So 2 by 440, 220. Or I can say inverse of frequency is time period. Correct. Then what is initial phase? Initial phase is 0.61. This is how. But you can see the solution here. Amplitude right. Omega given right. Cf is equal to omega by 2 pi. Correct. And inverse of that is this. Yes, yes. This is what we have to solve. Always don't try to put your pen on paper. Sometimes you have to analyze, like in your mind it should roll like anything. Then you will save the time. Some students will write given. What is given you know already. Then why are you writing once again? Because you have to solve the question within 1 minute, within 2 minutes. Then only your score will increase. So try to analyze while reading the question only. This is given, that is you have to find. That should be in your mind, not on paper. What you have to find, that should be on paper, directly equation, formula if it is required. Then cuttings and all will happen. Then that's it, answer you will get directly. So don't write, don't try to waste your time. So please follow whatever I said. So I hope finally you understood what do you mean by SHM and periodic motion oscillatory. Once again I am repeating, many students will confuse. Every periodic is not oscillatory. Example, revolution of moon, that is not oscillatory. Every 27.3 days it will repeat. So periodic but not oscillatory. But every oscillatory is periodic, like a person sitting in a swing and he was swinging, or pendulum clock. Periodically it will oscillate. And the periodic function means immediately you should understand that should be either sine function or cos function, which repeats its values periodically. And then finally we came to SHM. For SHM equation we had been done, that is f is equal to minus x power n. So based on n value we can decide the type of motion, right? The type of motion, n is equal to odd, that is compulsory oscillatory. N is equal to even, that is compulsory translatory. Then n is equal to odd, there is a special case that n is equal to 1, that is SHM. So that's all for the today's session. Till then, happy practice. Thank you.
For more such videos, please like, share and subscribe to Extramarks Test Prep YouTube channel.